Welcome back to A Question a Day Keeps a Bad ATAR Away. So today we've got, as you can see, flow diagrams. So it's part of networks, but it's specifically about flow. So if you take a look at this, what we've got here is we've got the way that a flow diagram will work is there's a source and there's a sink. So I always think about it, if you turn on a tap, that's your source. Okay. Now what happens is all your water will eventually flow down into the sink. Now, the way that we'll do this is the main topic here is it talks about max flow. And the way that you'll talk about a max flow is you'll find your minimum cut. Now, just to reiterate, a cut separates, all right, here, cut, it separates source to sink. Okay. So that means it stops any way from something to start at the source to end up at the sink. Okay. So that's what we're trying to do here. So it says the maximum flow from source to sink through the network shown above is, and so we need to find where we can cut through these that we find actually the smallest amount. Now, looking at this, I can see quite simply put that I'm going to have to cut through this top section, I'm going to have to cut through this middle section, and I'm going to have to cut through this bottom section. So the shortest way that we can do that is I can see I will have to cut through the one for this top section. Between the 5, 6, and 4, I'd probably cut through the 4. And then between the 2, 3, 6, I'd cut through the 2. And so I can see here that that line there will actually give me my minimum cut. And looking at this, if I add it together, 1 plus 4 is 5, plus another 2 is 7. My min cut here in this particular case is 7, so that's also my max flow. Okay, hopefully that kind of makes a little bit of sense. And as you can see, if I cut through there, I will definitely separate source to sink. And that's what it is. So just remember the way that you find your maximum flow is by actually finding your minimum cut. Okay, so for the next question, they get progressively a little bit more difficult. It says here the network diagram, blah, 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 shows a bunch of water pipes and sprinklers. And so the letters represent the sprinklers and the edges represent the water pipes. And it's all labeled here. Now it says here in the diagram below, an invalid cut has been marked on the network. Explain why it is invalid. So you can see here that they've cut through a bunch of different things here. Now, the issue with this cut is, can you see how normally, even if they don't label it, that beginning there, that's your source. Okay, now looking at all the arrows here, you can see here that eventually it all flows towards the sink, which is at the end. So as you can see, there is still a way for me to get all the way from the source to the sink. That's why it's an invalid cut. So you'd write something like, can still get from source to sink. Okay, that would be enough for your 1 mark. Okay, now the next part of the question says determine the max flow. Now again, max flow is a fancy way of saying find the minimum cut. And so looking at your diagram here, I'm gonna have to find where I need to cut through that will give me my shortest amount. Now, a lot of the time, you're gonna have to do a little bit of guess and check. So you'll have to trial and error. Now, just be careful. Normally what happens here is if I cut, let's say that 165, I don't have to cut that 80 because once I've cut that 165, there's no way for me to go and continue on. So I can see here, and I'm going to do a couple cuts just to get an idea. 135, 165, that should be 300. So I can see through here, that's still a cut of 300. Okay. And that means I could also cut the 300 at the front and at the back. So it's probably not going to be that particular cut there. Okay. Now, what I could do is I could take a look through this one here. I could cut through, let's see, 180, 150, and 95. That's more than 300. So I'm not going to consider that cut there. I could probably also do, let's say 180, 120. That's also going to be 300. 80, 100. If I cut through 180 and 95, if I cut through there, and I'll show you. Oops. My hypothesis is, so as you can see here, if I cut this 95 and I cut the 180, it completely separates source to sink. Okay, now as you can see, that because these have arrows, once it goes through the 150, there's no way for me to access it through that 100. So technically, I don't have to cut that 100. So looking here, I can see that there's 80, 180 and 95. And by looking at this, I would say that this here would be the minimum cut because that's less than 300. I'm just going to quickly check to see if there's any other cuts that could be done. Definitely not this one. I could do 180 and 165, but that would be more than 300. So I'm not going to take that one. So far, this is looking like my shortest cut. I could try go 120. No, I'd have to cut through all those. I can see that this here should be my shortest cut. And you can see with this question, there's a little bit of trial and error, a little bit of guess and check, but that seems to be the case here. So 275, and I believe based on the question, it's talking about liters per hour. So this is the max capacity, liters per hour. That there is my max flow of the network. Okay, hopefully that makes some sort of sense. And I'll catch you guys in the next one. See you later. Bye.